So let's do another example on solving first order linear differential equation. For this particular example, boundary condition is given to you, but you only need to worry about this at the very last step after you solve this differential equation. So recall, when you look at this method of solving the first order linear differential equation, the very first thing is you put into this format right here, get your integrating factor, apply this equation right here, integrate, and then solve for c. Okay, so in this case, let's do step 1. So for step 1, you must make sure that the coefficient of y prime here is equals to 1, and therefore this is what you have right here. Step 1 done. And the next thing, from here you can identify what is your px and what is your qx. Because this is pxy, this is your qx right here. And then the next thing, you want to get your integrating factor, which is e integral of px dx, which gives you as e ln 2x. Now, whenever you see exponential function and logarithmic functions in one term, you want to simplify them as much as possible. Before you can simplify them, a few things that you need to know. Recall, e ln m gives you m. And what else do you know? You also know that a multiplied by ln m is the same as ln m to the power of a. So from here, you can simplify to become e ln x squared, which gives you x squared. So when you compare these two functions right here, this one looks much more simplified. Okay, so once you've obtained your integrating factor, you can apply this equation right here. And then the next thing that you need to do is to integrate both sides. But before you integrate both sides, you must make sure you simplify it as much as possible. And all you need to do is to integrate both sides. So in this case, what you have is x squared y, 1 over 5 x to the power 5 plus c. You can isolate your y at this location during this step here, or you can apply the initial conditions to solve for c first. I'll apply it right here because it's easy to isolate c right here. So what does this mean? This means that when x is equals to 1, y is equals to 0. Simply substitute all the x in this equation with 1 and substitute y with 0. So what you have is going to be so from here, solve for c, and c gives you negative 1 over 5. Alright, so if you rewrite this solution, you have it as that. Or you can isolate y, and this becomes, and the condition is x must be bigger than 0. Thank you.